Hello everyone, welcome to Petrosys webinar on time structure map. My name is Mazlina Khalid. I'm a trainer and support person for Petrosys software. The objective of today's webinar is to guide users on how to integrate interpretation data from Petrel and generate time structure map using Petrosys grading technique. At the same time, I will also show you how to create mapsheet template and prospect polygons, which you can use in your volumetric calculation. For your information, this webinar will be recorded and made available in our website under the video section either today or tomorrow. If you have any questions, please feel free to ask me at the end of the presentation, or you can simply post it in the message area. So now, let's move on to the next slide, which is the agenda. I will first go through on a time structure map and grading. So basically just an explanation of what it means by time structure map and also grading process. And secondly, why we recommend using Petrosys grading for time structure map, followed by a short demo, and last but not least, summary. So what is a time structure map? A time structure map illustrates the area and depth of hydrocarbon reservoir. It also displays structural complexity of the prospect area. And the main process involved in time structure mapping is called grading. Grading is basically an estimation of surface values at a set of locations that are arranged in a regular space pattern, which completely covers the map area. So what Petrosys does during grading process is that it uses the algorithm picked by the user and generate a set of calculated data points at a regularly spaced interval and generate a continuous surface based on these calculated data points. So a grid is the same as continuous surface. And why do we recommend Petrosys grading? The first point is Petrosys has wide selection of algorithms and operations to create surfaces to feed the data set and geological interpretation. There are algorithms that can model data point trends and distributions, especially, for example, if you are working in a highly faulted area, or if there is geological structure such as channel with direction trends that you want to capture. Petrosys has grading algorithms such as kriging with external drift, and so on. The second point is it is easy for you to QC input data before the grading process started by using a tool called GIP Data Editor. And during grading, you can monitor your input data and cell sizes by looking at the RMS error report. And after grading process, you can use the grid editor inside the mapping module by using the spatial editor to delete any points that you want and perform regrading process again. And the third point is you can also easily drag and drop or use direct link of input data from oil and gas industry standard third-party software such as Petrel, DUG, Esri, OpenWorks, and many more. So this saves a lot of users' time. So now let's go to the demo. I'll minimize this slideshow. All right, so on my screen, on the left side of my screen, I have Petrel Gulfex project open, and I display the 3D seismic data survey, the 2D seismic line, and post the horizons values along the lines of top target two-way time values. And on my right-hand side is the Petrosys mapping module. Basically, what's the map sheet that you can see here is dynamic map sheet. It's not a proper map sheet. It's just a map sheet where you can display your data and check the extent of your data, or check if your data is available in your project or not. Okay. And for your information, in order for you to use the drag and drop option from Petrel onto Petrosys map, you will need to launch Petrosys from within Petrel by going to this main menu, which says Petrosys over here, and just click on the Petrosys button and click on the module that you want to launch. So now let's start with displaying the data onto Petrosys dynamic map sheet. So what I'm going to do is to take this 2D seismic survey from Petrel Input tab and drop it onto Petrosys Dynamic Map Sheet. And as you can see, it's only the 2D seismic lines without any two-way time data. So what I can do is just double click on the layer, and I have the seismic line selection toggled on. So what is this .sls file? It's just a data filtering seismic line. So please look up in your help menu or ask our support how to create this filtering file for seismic line. And I'll just change the styling a little bit. Just select stick because I don't want to post any short point information. I just toggle off the line name, and then I choose to display the interpretation data, which is the top tablet, and just use the blue arrow button to drop the horizon. Okay, or you can also click on the gray box over here and choose any horizon from the seismic horizon list. And choose the data type, elevation time, and next go to the ribbon map, and you can display your data in a form of color gradient so that it's easy for you to spot where are the structural highs and structural low. And you can also create your own color gradient, or just use the color gradient from the gradient selector that you see here. All right, so now that is done, just click OK, and you can see the ribbon map, the values posted as ribbon map. And next, what I'm going to do is I'm going to drag and drop the 3D seismic survey. So you can see it there, the cross line and the inline. And for example, I also want to toggle off the annotation just to make the map looking less crowded, as well as the survey annotation. So click OK. And now I want to bring over the top tablet 3D survey interpretation data. Okay, and as you can see, the 3D survey interpretation data for top tablet is displayed as Petrosys grid color field. So now that I have the area of interest, as you can see here, I can now start to generate a map sheet by going to Map Sheet, New, Beacon Map, Easting and Northing. So I have a map sheet file, which is automatically created as soon as you post any data displays. And to know the location of this sheet.def, just click on this yellow button over here. So it's basically in your project directory. You can have as many map sheet name inside a single sheet.df. You can also use a style from another project. For example, I can also use the map sheet from this Australia Flounder project. For example, if I go to existing map sheet, so these are all the map sheet style that I can use. But for the purpose of this demo, I will just create the map sheet from scratch. Okay, just click OK and click on the left mouse button. Drag your cursor to the other end of the map corner. Release the left mouse button, and I'll just type in the map title. And I'll just leave the scale as it is. For your example, if you want to change the scale, you can see that the sheet details, the width and the height changes as well. So the aim is to get 1 meter width times 1 meter height so that you get a nice printed out map sheet. And then I'll just edit some details just to make the map looking pretty. All right. I'll just change the sheet title size, annotation. select a custom scale bar and click OK. And I also want to post the easting and northing. As for the easting, top left of the map border, and change the offset values as well as the annotation size, and just use the reference grid type as ticks, and then change the annotation increment to 2000. And click on apply. So now you can see the easting and northing information posted on the map sheet. And next, I also want to post the lat and long information on the map. And since I already choose to post the easting and northing on the top left, so now for lat long, it's bottom right. I'll change the offset value, the annotation value, as well as change the reference grid style as lines this time, and the annotation increment. So once that is done, click apply, OK, and you have the lat long information posted on the map as well. I also want to post the title bar at the right side of the map. So I'm going to choose a custom title block, which is the Petrosys title block available in our system, and just leave the height and width as it is. All right. So now that is done, just click OK. And as you can see, this is the summary of the map sheet that I've just created with all of the details, the sizes, easting and northing, as well as the CRS. So just click OK. And one more thing to do is to fill up the title block. So I'm going to go back to map sheet, title block contents, and just type, for example, top tarbert time structure map. Okay, and then just click OK. So now that is done, now that we have a map sheet, I will bring over the Petrosys launcher so that we can start with the grading process. All right. And make sure that you save your map sheet. Okay. So again, this is the Petrosys launcher. For grading process, I am going to use the surface modeling module. Sorry for the error. Okay, so this is the surface modeling module panel. So if I go to create grid, as you can see here, I will need to type in an output grid. So I'll just type in top tarbert, and then just check the output projected CRS and some other information here. And I can now bring in the input data from Petrel input tab over here straight away by drag and drop. Okay, so let me bring this window here. I'll click on top tarbert, horizon interpretation, and just drop it onto the blank space there. So now that I have the data source selection window displayed, as you can see, most of the parameters have been selected. And the only thing that I need to do is just to select the 2D line survey and the filtering seismic line file, as well as the 3D survey. And just select the correct data type and click OK. And if you remember earlier on during the slide presentation, I did mention about editing your data before proceeding to grading process. So this is where you use the GIP tool editor. You activate, the GIP tool editor. You can choose to create and edit data before grading, and a sample data file name, same name as your output grid name, will be generated for future reference. Okay. All right. So now that we have put in the input data, let's move on to the output geometry tab. I will just use the map sheet that I've just created just now, and then just select the grid cell size to be 25 times 25 meter. If you want to know what is the proper grid cell size for your data set, please look into the help menu. As for seismic data, the rule of thumb is the average distance between two seismic lines, either 1/5 or half of the average distance in between two seismic lines. And if you have wells, if you have other sets of different data, the rule of thumb is slightly different. So please ask our support for advice. All right. So next, I will choose the methods. And since the data is distributed evenly, I am just going to use the standard grading as operation, minimum curvature grading algorithm, and bicubic interpolation method. I will also incorporate faults. I have fault file, which is actually a fault polygon file, which I just select just by using this yellow icon over here and just select it. And just make sure that the right surface is assigned, use Z values. And most importantly, Petrosys strongly recommend for users to grid inside faults, because we don't want you to miss any volumes inside the fault area. So it would be good to toggle on to grid inside faults. Okay. And as a side note, you can also use fault sticks from Petrel or any of the softwares listed in the drop-down menu over here. And also from these fault sticks, you can generate a fault polygon. This fault polygon, you can edit or you can push it back to Petrel. But if you have a fault framework or fault model, so that supersedes the fault polygon that you generate in this process. And since the fault sticks data that I have is not suitable for this demo, I will just use the fault polygon instead. All right. And as for clipping, smoothing, reporting, and contouring, all of these steps are optional. So I'll just leave it as it is. And one last thing is you can go to summary and check your grading summary. Well, basically, I think the important thing that that you should note out of this grading summary is the number of rows and columns, just to give you an idea of how big the grid that you are going to generate. Okay, so I'll just click OK, and the grid process is going to run. And this is the GIP editor displaying the data points that Petrosys is going to use to generate the grid. So if I go to edit, I can choose to delete points, add points, change points, values, and so on. And I can also view the data differently. For example, if I want to view it as a histogram or cumulative histogram, I can do so, or even statistics. So let's just go back to the plan view, and I'll just straight away perform the grading process. And as the grading runs, you can see the RMS error values for each completed pass. And the normally the RMS value will decrease until the pass completed. And will this indicate that the input data that you use to generate the grid and the cell size that you use is okay. But if you find out that the RMS value increase instead of decreasing, so please check back your input parameters, or the cell size that you use, and change it so that you have a good grid output. Okay. And in order for you to change the details, in case you want to rerun the gridding process, just double click and you can easily go back to the input parameter. And one more thing, you can also save this task just by going to File and save the task. Just give it a name. So I'll just give it any name times structure, and the extension is a .tsk, and save this task. All right. So now that I have completed with the grid generation, I am going to display the grid by going to Display, Grid, Color Fill, and the software automatically picks up the grid that we just generated. So this is basically the statistics information with the cell size and the Z minimum and maximum value. And I toggle on the display color fill, and this is the color gradient that I'm going to use, which is Petrosys default. And as for contour, I choose to display contour for every 20-meter interval. So once that is done, just click OK, and the grid will be displayed. All right. Okay, so now that we have the grid, I will show you how to create prospect polygon. I happen to test the data, and it seems like the lowest closing contour value is about 1780. So what I'm going to do is go back to the grid color fill and change the maximum value to 1780 and click OK. So now you see that this is, for just an example, a prospect that I would like to map. And the purpose of a prospect polygon is so that when you generate volumetric, it will just give the result from one prospect. And it is advised for you to not generate a polygon which crosses to another potential prospect or something similar. Okay, so now I will just go to, I will create the polygon prospect by going to Edit, create single polygon, and just type in a polygon file name. So I'll just put a prospect, and then just type in a polygon name, for example, prospect 1, and click OK, and start digitizing around this prospect and double click to end the polygon creation. And you can choose to change the fill style, make it transparent, and also display the polygon name, and click OK. So now you have the prospect polygon posted. All right, so go back to the grid color fill and remove the maximum value and just click OK. So now your two-way time grid is completed. Another thing that you can do to, let's say you want to remove any spike values, or you want to edit the contour in certain area of the grid, you can do that by using Spatial Editor, or in other words, Grid Editor. All you need to do is just click on the grid layer, right button click, go to Edit, and this will launch the Spatial Editor window. And say, for example, I want to change this contour, this one maybe, or just select the whole contour there. I can choose to interactively bend selected shape, so it's easy to do that. I can also choose to take one contour and use this eraser over here. If the editing circle is too big, you can always change it to be small to cover a smaller area of editing, and just clean up the contour area and then redigitize the contour. And then pick the contour back and do some smoothing. Okay. And once you do this, you can actually perform localized regrading, basically around a buffer area. You can choose the buffer area. Say if you put it, if you want the changes to affect 1000 meter away from the changes that you made, you can do that, or change it back to maybe 500 and click OK. And the grading process will just regrid around that buffer area. Okay. And so once that is done, you can also go to edit, change to grid nodes. And say if you want to clear some of the values here and regenerate the grid in that area, just click on this button over here and set value to clear value, and just minimize the edit circle tool and just go around this area, and then click on this button here and create a polygon around it. So what's the software is going to do is use the surrounding values to regenerate the values in the missing spot. All right. So once that is done, just double click and Petrosys will do a localized regrading. You can also choose to recontour or regrade the whole grid, not only the change area. So it's up to you. All right. So once that is done, make sure that you save and just close the spatial editor window, and you have your changes implemented. Another thing that I would recommend to make sure that the display list that you have is looking more organized is just to go to layers and create a group for the map elements. Let's say if you want to separate the data layers between the map elements, you can do so. So just create a group called Sidebar. And if you notice, we haven't posted the location map, the color bar, the legend, and so on. So we are going to do this now by going to Display, Map Elements, Location Map. Just click OK. So this is the built-in location map. You can adjust the zoom area so that you can see the coastline versus your project area. And again, go to Display, Map Elements. This time choose North Arrow. You can choose any of the North Arrow available here, or you can have your own image. Okay, so just make sure that the placement is in the map sheet title bar. Click OK and move it down. Maybe minimize it. And next, I want to display the color bar. And I have written a text over here which says the unit of the color bar. And just bring it up over here and adjust the size. And last but not least, the legend. So you can actually add more legend or item to your legend, but I am just going to rename this polygon here to prospect polygon, and just leave other tabs as it is and click OK. Minimize the size and bring it into the title bar area. So don't worry about this white spots. All you need to do to get rid of it just by using the refresh button. So once that is done, select the legend color bar North Arrow location map and bring it inside the sidebar so that you have all of the map elements in the sidebar group, and the rest is just data layers. Okay, so you can change the sequence of the data layers in the display list as well. So once that is done, just save the map sheet again and also the map files. All right, so that's the end of the demo. Now let's go back and have a look at the slide summary. Well, in order to have a complete time structure map, you need to generate grid and contour, and maybe sometimes put a prospect polygon, and it would be good if you can create and save a map sheet template so that you can use it for other project or other horizon. As for final thoughts, time structure map can be created directly using drag and drop from Petrel or by direct linking to many other software vendors. And secondly, Petrosys strongly recommend grading inside faults using suitable methods, such as the basic method or the three-step grading method or the dump fault from grade file and regrade method. And last but not least, the map template can be used to map other horizons from the same or from a different project. I have a workflow which I used to during the demo just now, and this video is going to be posted in YouTube either today and tomorrow. So please feel free to try and recreate your own time structure map using the instruction here. So do you have any questions? I need to unmute. Sorry, just give me some time, yeah.